Welcome to this video. In this video, we'll look at dimension analysis. Those who are doing introductory physics, such as Physics 101, Physics 111, and Physics 110, and other codes, just the same. Now, you know physical quantities, and you know their units. Dimension analysis, it comes to help us understand the relationship between physical quantities and their units of what? Measurement. So it helps us understand the relationship between physical quantities and the units of measurement. That's why dimension analysis is there. Now, every equation, for example, must balance on the right side and on the what? On the left side. For example, we know that 1 kilometer makes how many meters? It makes 100 meters. Okay, so 1,000 meters. If you get any kilometer and you try to convert it to meters, should give you the same on the left side and on the right side. Now, whenever I've been taught to convert something or units in physics or chemistry, use dimension analysis because it's the most recommended one. Dimension analysis is also called factor label method. Factor label method, or others call it a unity factor method, or you can call it unity factor method. That's the other name. So in case they don't use dimension analysis, they use any of these terms. It's just the same as dimensional analysis. Now, when you are checking if, for example, a physical equation is correct or not, you need to check that on the right side it gives you the same as what on the left side. Now, let's just check for this example. We know that speed is equal to distance, okay, divided by what? Time. Let's prove that the left hand side is equal to the right hand side. How can we check for that? We know that things like time, okay, they are measured in what? Seconds. Those are their physical quantity. You did those in grade 11, 10, sorry. Distance, which is measured, is just length, which is meters. So here we'll be using initials. For time, we use T. For distance or length, we use L. For velocity, it's L stroke T, just like that. So let's see that if this equation is dimensionally correct. How can we prove that? Speed, we know that it's meters per second, right? Let's keep it this way. It's a speed is meters per second equal to distance is measured in meters, time is measured in seconds. So we need to show that the right side is equal to the left side. Meters is just length, so I'm going to put L over. This is the second for time, so I'm going to put T, like I said, equal to meter is just length over. These are seconds, just the same as time, so use capital T. The question is that, is the right hand side equal to the left side? Yes, so this equation is dimensionally correct. So that's how you can use dimensional analysis to prove. Let's look at an example. The example says, check the correctness of physical equation. Distance is equal to initial velocity times time plus half acceleration times squared. In the equation, S is the displacement. You know that displacement is measured in meters, right? Which is just length. U is the initial velocity, V is the final velocity, and A is the acceleration, and T is the time in which changes occur. So how can you prove that this equation is correct or is dimensionally correct? Let's write it all here. The displacement is equal to initial velocity times time sorry, plus half AT square. Now, there's something that you have to know when it comes to dimensional analysis. You ignore, and I repeat, ignore constants. Ignore constants, such as these numbers. Ignore numbers as you are dealing with what? Dimensional analysis. So we are going to ignore those numbers. Now, this is just distance. And you know that distance is measured in meters. I'll first do this. Okay. It's just length. Velocity is measured in meters per second. I'll keep it that way. Time, I'll put second here. I'll multiply there. Plus. I'll ignore this half here. Like I said, ignore constants. Acceleration is meters per second squared. So put that. Time is second squared. See, Nika? Now we replace those what meters mean in terms of dimension. It's just length, which is L. So here is just L. So we put that is equal to meter is just L over T. Hope you are following. That's just T. Plus, that's just L over T squared. And this just T squared. So we are saying L is equal to this T and that T, they cancel me with L here. Plus this T squared and T squared, they cancel me with L. So L is equal to L plus L is 2L. Right. Now remember this point here, ignore constants. This means L be equal to L. So this equation is correct. So that for every equation that be given, you have to prove this way, and they should always come out the same. If they're not coming out the same, that means that equation is not dimensionally correct. All right. So the other part is why use dimension analysis? Why use dimension analysis? The first reason is that to check the consistency of a dimensional equation. 2, to derive the relationship between physical, like I said in the first part of the video, physical quantities in physical phenomena. 3, to change units from one system to another. All right. We'll do more or examples on dimension analysis. For now, this is the introduction. Don't forget to subscribe to my channel, for my Facebook page. I'll see you in the next video.